A pleasant day, everyone. I am Lorelina Abulag. I hope you all are doing well and we're excited to acquire new and informative knowledge or lesson in our time today. Because, as you know, our topic might a little bit difficult para sa iba, but definitely this will make you interested. Pero, ayun nga, our topic is something very, very important and that concept of kinetic energy and about something called work energy theory. Okay, so when we start to talk about energy, most of us, the first thing that comes in our mind is these images in front of us, diba? Maybe lightning bolt, kuryente, o di kaya something about battery, diba? O kaya yung favorite natin na linya yung naubusan na ako ng battery, something like that, ano? But in physics, in classical motion, which is what we're studying here, diba? Ang sabi ron, an object will not change its motion unless a force is applied or acts on it. So, itong mga images na nandito sa harapan nyo, doesn't have any connection about sa energy na sinasabi natin sa pag-aaralan natin. So, when we say energy naman, well, energy has a very specific definition. Just like work, it had a very specific definition. Energy and work, they are connected. We're going to talk about that. Okay, so let's now talk about that. Let's say we have this thing called kinetic energy, and I'm going to abbreviate that into KE. Means kinetic energy, yun nasa formula natin. And it's very simple equation, di ba? KE equal to 1 half times m, which is the mass of the object, times the velocity squared. To illustrate, very simple. If you have some ball, take imagine you have a baseball or something that has a certain mass, okay? Ito yung m sa ating equation, the mass. You throw that baseball and has a certain velocity. Diba? There's a certain velocity when you throw a baseball, diba? Then all you have to do is to take the velocity squared, tsaka multiply mo siya sa mass, multiply mo ulit sa by 1/2, then that's all. You have now what we call kinetic energy. That's how we compute it. So basically, you can regard this as the equation as the energy something possessed when it moves. Okay? Simple as that. Pero medyo ano din, said of that the kinetic energy has unit of joules. Okay? While work in physics measure of energy transfer that occurs when an object is moved over a distance by an equal force, at least part of which is applied in the direction of the displacement. Kapag, okay, so sabi ko nga kanina, energy and work has something to do with our discussion today. And kapag sinabi naman nating energy in physics defined as the uh, ability to do work, which is the ability to exert a force causing displacement of an object. Okay, so kinetic and work, there's something to do with our discussion. Uh, Yun. So, nakakalito man, pero work and energy, uh, ay similar sila ng units. Pero, ayun, the unit of energy is joules, while the unit of works is also joules. Okay? Same unit sila, pero magkabi sila ng formula, but they are connected to each other. So, you find that work has a unit of joule, the kinetic energy has a unit of joule din. Para mas maintindihan pa natin, sabihin natin na meron ka ritong box. Ayan. Ayan, yun nasa um, harapan natin. You push on this box with some force, which is the F. Okay? Yung nakasulat dyan na green na F. Just then later, the box ay syempre gagalaw. Kung makikita nyo rito sa right side, di ba, nag-iba yung pagkakadrawing niya, parang may mga broken lines na siya. Uh, sa in art manner, it represents the box was moved. The box was moved, di ba? Okay, so going back, you're still applying that force even though it's moved. You're applying that force throughout the whole thing. Now, initially the box was at rest, hindi ba? Kasi una nandun yan, tsaka mo siya nilagyan ng force. You exert force. Initially, it is zero or at rest. Di ba? So, obviously, sinabi ko na, the velocity was equals to 0. Tapos, whenever na ginagalaw natin to, as we apply force on it, over here sa kanan na bahagi, based on our presentation, makikita nyo yan dito sa natin, presentation, it's going to eventually have some final velocity greater than 0. Kasi yun is exert force. So, if kung kanina, at rest siya, that means equals to 0, since you exert force, then the velocity will be greater than 0. So, nakalagay dyan, velocity initial velocity is equal to 0, which is at rest, and then you exert force, velocity, final velocity will be greater than 0. Okay. Ayun. Ang sinasabi lang naman rito, since the velocity is at rest, meaning it is equal to 0. Pero if you push na, then it will have some velocity that is not equal to 0 na. Ulit ako, di ba? Okay, anything that is greater than 0. This could be 10 meters per second or something meters per second. Nonetheless, obviously, you're moving it through some distance. Yan, certain distance over here. It could be over here, papunta sa left side or papunta sa right side. Kapag may itinulak ang isang bagay, of course, it has a mass o bigat. Yan, nakikita nyo. Yung box dito, yung box sa left, box sa right, may nakalagay sa taas na M. That's represent mass. Now, let's start with this illustration. The box, as you push this object through distance or the D, you do work on the object and not energy. You do the work. When you push it, you do the work. That's the work. Okay? Because you have to get it moved. So you are doing work on the object. That's the work that we are talking about. Okay? So the work done on the object was simply F times D force times distance or kaya naman, ayan nakikita nyo dito yung parang arrow W, that's represent work, equals to F times, okay, that's it, F times D times distance. O kaya naman, if the force was not in the direction of the motion, like it is here, then ang mangyayari is F or force cosine theta times distance or D or theta or theta. Or theta is the angle of the force, okay? Theta is the angle of the force. Kaya the object has an acceleration now. Pero, paano ito nag-accelerate? Siyempre, the force is equal to the mass times acceleration. So, ayan, nakalagay dyan. So, sa baba, object acceleration is equal to the mass times acceleration. Yung nasa presentation natin. So kung alam ko yung force ng tinutulak ko in this block sa left side, and at the same time alam ang mass, then this force is equals to mass times acceleration. Will predict what acceleration I will have, di ba? That makes sense, di ba? As you know, the force and mass, you will identify its acceleration. Ganun lang. So, kasi, di ba, when you push on the block, it has an acceleration which then speeds up its velocity. And that's why in this presentation, na move object, yung may arrow, its velocity now is non-zero. Okay? That's the explanation why velocity, when you move it, it is now non-zero. So, as the result of the object acquiring an acceleration, our final velocity now, which is ito, yung sa right box, yung move object, yung velocity greater than 0, it will now obviously going to be greater than the initial velocity. Yung our initial velocity kanina, di ba, is equal to 0. Okay? So, well, overall, to not confuse, very simple lang naman ito dito. When you are pushing a block, then you are doing work on the block. And the block speeds up, and then the block speeds up this is will enter now, we are saying velocity of the final velocity. Okay? The final velocity is greater than initial velocity. Ito yung equation na may linyang yellow. Now, because of our definition of the kinetic energy, if the final velocity, which is ito, yung may linyang yellow, final velocity is greater than the initial velocity, then ibig sabihin is the final kinetic energy of the box has to be greater than the initial energy of the box. So we do all this. So when we do all this, the kinetic energy increases. Okay. So to summary the work, to summary, the work you do on the box goes into increasing the kinetic energy. Now, let's move forward to work energy theorem. In this part, as you can see in part of view, the equation the following is first, the net work done on a system that was a box get to equal to final kinetic energy minus the initial kinetic energy, which is equal to the change delta. Delta. The change delta. Delta means change. Okay? So, equal delta kinetic, kinetic, kinetic energy. Yan, yung KE, uppercase na KE, kinetic energy, tapos may F sa baba, that is final kinetic energy, and KE na may I sa baba, that is the initial kinetic energy. To put this equation simply, tulad ng sabi ko kanina, you do work on a system in the case, it's just a box. Then, it's a box. Then, you do some work on that system where that work must go somewhere kung saan ito it goes into increasing or changing your kinetic energy, and the change is governed by the final kinetic energy minus the initial kinetic energy. In this case, the initial kinetic energy was zero. Ulit-ulit ko sinasabi kanina. Because the box was stationary or not moving. So, every joule you put in must have increased its final kinetic energy because its velocity increased. So, if we were going to write it more clear, sa next ano natin, it will be the net work done on a system would be 1/2 and mv final velocity squared. That's just final kinetic energy of the system. Yung F minus 1/2 and mv m initial velocity squared, which I just said that I represent in initial kinetic energy of the system. So, ito yung tinatawag nating work energy theorem. And katulad lang din ng sinabi ko pa kanina, every joule you put has to go somewhere. And since pinag-usapan na natin ang kinetic energy, you are pushing things that the work that you put in. With that, let's now try to solve a problem. Since alam na natin yung kinetic energy and what is the work energy theorem, let's now solve a problem. Ayan. In our example, a 0.15 kg baseball is shown a speed of 40 meters per second and with an initial angle of 30 degrees. What is the kinetic energy of the ball at the highest point in its motion? Yun yung ating problem. Hinagis daw yung bola ng baseball. Siyempre, obvious naman na pataas ito at saka bababa. And based on our problem, it was thrown with an angle of 30 degrees. Given na siya. And the initial velocity is 40 meter per second. Given na rin siya. Ayan yung velocity ng bola na pataas. The 40 meter per seconds. Also, yung baseball itself ay meron mass na 0.15 kg. Given na rin sa ano natin, sa problem. Which is, ayan, yung naka-illustrate. The green, nakalagay na dyan. Dito sa left side natin. Ang tanong sa problem nga lang natin, anong kinetic energy nito at the highest point? Which is, ito yung kulay pink. Diba? May naka-arrow din dyan, nakalagay din, highest point. To solve this, let's now follow the given formula of kinetic energy, which is the kinetic energy is equal to 1/2 mv squared. Sa problem nga lang natin, di natin pwedeng gamitin yung 40 meters per seconds kasi hindi naman tinatanong sa problem natin kung anong kinetic energy nito mula sa baseball. Yung green na parang bilog dyan at the corner, di ba? Na illustrate ko na yan dyan. Tignan nyo lang. Ang itinatanong sa problem natin ay kung ano yung kinetic energy ng highest point. So, yung highest point daw. Para malaman natin, we have to make sure muna na tama yung gagamitin natin velocity dito sa velocity squared sa formula natin. So, we have to find the velocity squared muna. Di ba ang nangyari ay binato yung bola? Kaya yung bola ay tataas at bababa. So, in the highest point, the vertical motion, the up and down motion is 0. Kaya yung horizontal motion, ang ano natin, ang hahanapan natin ng velocity squared. Okay, so para mahanap yan, the x component ng velocity natin dito sa green na bilog will be equal to 40 cosine 30 degrees. Ayan yung component ng ating velocity. Then, substitute mo lang naman kasi yan. Then, if we will calculate this na using calculator cosine 30 times 40, we will get 34.6 meters per second. Ayan, nakalagay dyan. Naka-arrow na. Sa baba ng formula, tignan nyo lang. Throughout the motion, okay, x component is not act upon by gravity because gravity does not act in that direction. Kaya, itong nakuha nating sagot na 34.6 is constant. Okay? Next, component naman is 34.6. At the apex, which is the highest point, ayun, apex is dito, the highest point, the y component is simply 0 kasi walang y component. Kahit pa inahagis mo ang bola pataas, the y component goes to 0 before it comes back down. Kaya yung velocity, yung total velocity ng baseball dito sa apex o highest point ay 34.6 meter per second, which is we will going to use to solve or to find the kinetic energy of the highest point. Okay, so the x component sa problem natin is the same pa rin. And ang y component naman ay 0. So the velocity at the apex is 34.6. Okay? So, to answer the question in the problem, when we multiply 1/2 times mass mass, which is the 0.15 times 34.6 squared, ayan yung nakuha natin kanina when we do the 40 cosine 30 degree, ang magiging sagot natin is equal to 89.8. And anong sabi ko kanina ulit? Yung units ng energy, di ba, joules, katulad ng work. Energy and work has the same units. And kinetic energy is equal to 89.8 joules. That is the answer in our problem. That's how you find the kinetic energy. Malinaw ba? Yeah, medyo mahaba-haba, medyo madali lang naman sa aptitude, find this, and then read the problem properly. Okay, that's all for today. Thank you so much for listening. Bye-bye.